So hello and welcome everyone. Welcome to Kreatryx. Welcome to Unacademy. So in these sessions, we are going to start the communication system and you are going to study the communication system like never before. So before that, let me introduce myself. My name is Vishal Soni and I have cleared ESE examination 2 times, both times in double-digit rank. And I have also served as a Group A gazetted officer in Indian Railways and in Indian Telecommunication Services. And I have also cleared a lot of public sector examinations. So right now I'm teaching on Unacademy and I really feel proud to be the part of the Unacademy team, because Unacademy is the revolution in the field of free education and in the field of affordable education, and we as a team are really looking forward for every student to just come onto the Unacademy platform. You can attend the special classes, you can come onto this YouTube channel and you can stay connected with us so that you can understand the quality education and you can understand the efforts that we are putting in, so that every student of this country, whether he stays in a village or he stays in a town, should get the access of the content, that too in a very affordable prices, and he can also or she can also clear the examination with the best possible ranks. So right now I'm teaching on Unacademy with more than 15 million watch minutes in the overall duration and 2 million watch minutes in the last 30 days. So I am right now the top educator in Unacademy across all the branches, having rank 4 right now. And you can also follow me on Unacademy on this particular link. So you can go and follow me on Unacademy. Apart from that, my advice to every student is that how should you crack the examination and what are the components to cracking the examination. So the first question that comes to the mind, that can anyone prepare from the YouTube? Yes, you can prepare from the YouTube, but you should develop or cultivate some habits in yourself. For example, you should be very much disciplined. You should arrange the extra resources. For example, the PDFs you have to arrange, the test series you have to arrange by yourself, and most importantly, that self-discipline you should be containing in yourself, so that you can be very corrective manner and you can approach the examination in the best possible manner. So all these things you have to arrange yourself. The sense of competitiveness you have to cultivate in yourself, because the audience on the YouTube are not that much of competitive in nature, or maybe you cannot feel the competition which is present right now. So all these things are the part of the journey if you want to prepare through the YouTube, or maybe if you want to prepare through the free resources. Apart from that, if you want that you should get complete content, then this is the YouTube channel. On this YouTube channel itself, all the free content are available. You just have to go to the playlist. All the subjects are completed there. You just have to go and watch all the lectures one by one. Definitely will be getting benefited. But the extra things that I have told you, that the self-discipline and the sense of competitiveness and a lot of things you have to arrange by yourself. If you are comfortable in that, then you can do that. Apart from that, you should also have Unacademy learning app, so that the special classes you can attend. A lot of educators in this country are actually providing the special classes, that too absolutely free of cost, so that you can get the quality content in the best possible manner. Apart from that, there is also another component for you, which is Unacademy Plus. So on Unacademy Plus, what is your job? You just have to study. If you join this Unacademy Plus, you do not have to worry about the crash courses, weekly test, doubt solving sessions, the language barrier, rank improvement batches, live classes. So all these things will be taken care by the Unacademy. You just have to take the Unacademy Plus subscription and you have to come on to the Unacademy. You will be daily getting the live classes. You will be getting the crash courses. When you will be getting the crash courses? When the syllabus are completed. You will be getting the weekly test in the form of quizzes. Every fourth class is the doubt solving session, which is the major you can say the component or the major impact will be creating on your studies will be this doubt solving group. Because until and unless your doubts are not being cleared, until and unless you are not able to clear your doubts, you will never get the confidence in the subject. So once you come on to this Unacademy Plus, every fourth class is doubt solving session. Apart from that, various other doubt solving sessions are going on. So ultimately you will be getting your doubts cleared and you will gain confidence in the subject. The language barrier will not be an issue, because the batches will be running both Hindi and in English, and rank improvement batches will also be there. So all these things are the component of this Plus subscription. Once you come on to this Unacademy Plus, you do not have to be worried about your self-discipline, your competitiveness nature. Everything will be present on Unacademy, because a lot of other students will be there. Since the classes will be live, you can also watch it recorded later on. So the discipline automatically comes, because you get the idea that you will be having the daily live classes. Apart from that, there is also one iconic subscription. In this iconic subscription, the game changer is this personal coach. So this subscription is for them who thinks that their basics are weak, or those who are talented but they needs a continuous push. So this personal coach will be guiding you throughout your study. He will be giving you the study planners. You will be getting the study booster sessions. Once you will get the test, you will be getting the analytics. Analytics plays a major role in improving yourself. We as a teacher also get our analytics so that we can improve on the daily basis. So once you start getting the analytics, you will be also improving massively on the daily basis. Apart from that, there will also be the guidance for the mains once you clear the prelims, and there will also be the guidance for the interview once you clear the mains. So once you take the iconic subscription, all the benefits of the plus are included by default in this. And if you take the plus subscription, then also these things will be included in that, though, so that will also create impact in your preparation, so that you just have to study rest of the things.
Hello friends. So in the last lecture we discussed very important parameter that whenever a continuous random process, that is continuous time random process, is observed at any particular time instant, it may result in continuous random variable or a discrete random variable. Similarly, when a discrete time random process is observed at any particular instant n equal to n naught, it may result in continuous random variable or discrete random variable. So now, in this class, we are interested in the statistical parameter of continuous time random processes. So we want to study actually the continuous time random processes and their statistical parameters. So first of all, let us try to understand what does the statistical parameter of continuous time random processes exactly stands for. So whenever we talk about the statistical parameter of continuous time random process, it actually means that we are interested in statistical parameter of continuous time random process at different time instances. So we know that whenever a continuous time random process is observed at different time instances, it results in random variables. So whenever we are interested in the statistical parameter of a continuous time random process, which means we are interested in statistical parameter of random variables obtained by observing the continuous time random processes at different time instances. So what should you notice that whenever we are interested in statistical parameter of continuous time random process, we are basically interested in the random variables obtained by observing the CTRP at different time instances. So before proceeding on to the statistical parameter, let me give you a brief recall about the random variables. Suppose we had a random variable x, then if this x was continuous random variable, then you had calculated its CDF, which was probability of x less than small x, its PDF, which was differentiation of CDF. Similarly, when x was discrete random variable, then you had calculated three parameters. One was PMF. So the PMF was something like this. Then you calculated the CDF, which was probability of x less than or equal to x. And then you calculated the PDF, which was, so this was the PDF. So in case of CRV, we calculated two parameters, CDF and PDF. And when X was DRV, we calculated three parameters, which was PMF, CDF and PDF. And we had commented there that when X is DRV, the CDF will always be in the form of staircase. It will always have impulses in it. So this we have already discussed in the chapter of random variable. So let me extend this particular knowledge onto this random variable concept. So initially, I would like to discuss the first order statistics of continuous time random process x of t. So we know that if I have to study the statistics, then first of all I have to form a random variable by observing this random process at x of t naught. So at this particular instance, we can observe the first order statistics of this particular continuous random process. So we know that if this is your continuous time random process, then this is nothing but a random variable, and this random variable can be either continuous random variable or discrete random variable. So in the first case, I am considering that this x of t naught is continuous random variable. So I can write this x of t naught as CDF. So this is your random variable x of t naught, and this is the values taken by x of t naught. So you can write it as probability of x of t naught less than or equal to x naught. So this is in the symmetry. There the random variable was x itself. Here the notation of the random variable is x of t naught. So instead of x, I am writing x of t naught. Instead of x, I am writing x of t naught. So what is this small x naught? This is nothing but the values taken by the random variable x of t naught. There the small x was, here it is the small x, it was the values taken by random variable capital X. So similarly, the values taken by the random variable x of t naught I have denoted as x naught. I can also calculate the PDF. The symbol of the PDF will also be same. This will be x of t naught, x naught, and to obtain it, I will differentiate this CDF with respect to x naught. Since it is the case of continuous random variable, so we can obtain only CDF and PDF. Let me explain the second case. In the case 2, I am assuming that this x of t naught is discrete random variable. So here I have to calculate three parameters. So first one is PMF. So the PMF will be x of t naught, x naught I, and you can write it as probability of x of t naught equal to x naught I. What will be the CDF? The CDF will be same, which means the definition of the CDF will become probability of x of t naught, which is equal to probability of x of t naught less than or equal to x naught, and the PDF becomes fx of t naught x naught as the function of fx t naught x naught upon del x naught. You can also write this PDF as summation of xt naught x naught I del of x naught minus x naught I, or this becomes summation of probability that x of t naught equal to x naught I del of x naught minus x naught I. We know that whenever x is discrete random variable, you can write your PDF as a function of PMF, or the PDF is always written by using PMF. So you can take the inspiration from the discussion of the random variable and you can extend this logic further. So this was all about the first order statistics. Now let us try to understand the second order statistics. So in the second order statistics, of continuous time random process x of t, what we will do, we will first of all try to take some inspiration from the concept of the random variable. So in case of random variables, we know that suppose we have two random variables x and y. Now if these random variables x and y are continuous random variables, then we can define the joint CDF as xy x comma y, which is x less than or equal to x, y less than or equal to y. Similarly, we can define the joint PDF, which was fxy x comma y, and we will two times differentiate this CDF, one with respect to x, another with respect to y. Similarly, if this x and y are discrete random variables, then we can define the joint CDF as fxy x comma y, which is probability of x less than or equal to x or y less than or equal to y. Or we can define the joint PDF as fxy x comma y. It is again becomes two times differentiation of CDF, and another parameter we can define, which is joint PMF. So the joint PMF becomes probability of xy xi comma yj, which means it is equal to x equal to xi comma y equal to yj. So this much we have already discussed in case of random variables. Now let us try to extend this discussion for the random process. So whenever we are interested in second order statistics of x of t, what we will do, we will take two samples of this. So I am taking one sample at x of t1 and another sample at x of t2. So I am observing my random process at two different instances. So this was the continuous time random process, and obviously these two will be random variables. So again here I am considering case 1, in which these two random variables x of t1 and x of t2 are continuous random variables. So I have to define the joint CDF. The joint CDF will be notation something like this. So this is very similar notation for the joint CDF as we discussed in random variable. Here instead of random variable capital X, I have written x of t1, and instead of random variable capital Y, I have written capital X of t2, because these two are random variables, and here x1 and x2 are values taken by xt1 and xt2. So you can write it as probability of x of t1 less than or equal to x1 and x of t2 less than or equal to x2. So here just the notation is little bit different. Instead of random variable x, we are writing x of t2, and instead of random variable y, we are writing x of t2. And here this x1 is values taken by random variable x of t1, and x2 is also values taken by random variable x of T2. Similarly, you can define the joint PDF, and the joint PDF will be xt1 xt2 x1 x2. We will differentiate the joint CDF two times, one with respect to x1 and another one with respect to x2. Now let us try to understand the second case also. In the second case, let x of t1 and x of t2 are discrete random processes. So here, first of all, I will define, these are discrete random variables. So first of all, I will define the joint PMF. So the joint PMF will be x of t1, x of t2, and here I am writing x1I and x2J. So you can write it as probability of x of t1 equal to x1I, comma x of t2 equal to x2J. So this is the joint PDF. Again, the joint CDF will be probability of x of t1, x of t2, x1, x2, and it becomes probability of x of t1 less than or equal to x1, probability of x of t2 less than or equal to x2. And finally, you can also define the joint PDF for discrete random variable case. So the joint PDF becomes xt1, xt2, x1, x2. So it can be written as del 2 fxt1, fxt2, x1 comma x2 upon del x1 del x2. So all these discussions are important. So till now we have discussed the first order statistics and the second order statistics. Now let us try to understand how to calculate the mean of a random process. So this x of t is your continuous time random process, and we are interested in the mean of the random process x of t. So we want to calculate expectation of x of t. Again, we will look for random variable and try to seek some inspiration from there. So suppose x is a random variable. Now this x can be either continuous random variable or discrete random variable. We know that whenever you have to calculate x bar or expectation of x or mu x, we always follow two methods. First one is, if x is continuous random variable, then we used formula of something like this. And whenever x was discrete random variable, we used this particular formula. So this formula was used whenever x was continuous random variable, and this formula was used whenever x was discrete random variable. Here the fx of x is PDF of random variable capital X and small x is values taken by random variable capital X. Similarly, here also this probability of x equal to xi is PMF of random variable capital X, and this xi is values taken by random variable capital X. So in the similar fashion, we will do this discussion. Similarly, you can write g of x or g of x bar as minus infinite to infinite fx of x dx. Similarly, here also you can write g of xi, probability of x equal to xi. So here, whenever x is continuous random variable, this g of x will also be continuous random variable. And here, if x is discrete random variable, this g of x will also become discrete random variable. Here you should notice that whenever we have written the function of x, then we do not need the PDF of gx. Rather, here fx of x is PDF of random variable x. Similarly, here also this x equal to xi is PMF of random variable x. So you should notice that whenever random variable is written here or the function of the random variable is written here, we do not need the PDF of this function of random variable. Rather, we just need the PDF of x. So you can refer this point from the random variable chapter also. Here I am just giving you the basic idea behind it. So let me calculate the mean. Suppose I have a continuous time random process x of t. So obviously this x of t will be some function of time as well as random variable. So now let me denote this random variable with some parameter, say m. So here this m is nothing but a random variable for us. So now we have to calculate the mean of the random process, which is sometimes written like this, or it is also written as mu as a function of t. So what we have to do, you have to calculate the mean of random process. The mean of random process sometimes is also known as ensemble of random process. So to calculate the mean, what you should do, this is nothing but expectation of t comma m. So to calculate the mean, you know that if I will write this f of t comma m, then this t is your time and this m is your random variable. So I should write minus infinite to infinite f of t comma m f m small m dm whenever m is continuous random variable. And here this capital M small m is representing the PDF of continuous random variable m. Similarly, you can also write it as f of t comma capital M probability of m equal to mi whenever your m is discrete random variable, and this probability of m equal to mi represents the PMF of discrete random variable m. So these two functions are very important. Now sometimes it is also written as expectation of x of t equal to mu as a function of t, or you can directly write it in the function of x of t. So it is written as minus infinite to infinite x fx of t x dx when we are observing this random process at t, or it can be also written as x probability of xt equal to xi when I am wearing I here. So here when x of t is observed at t equal to t, so it starts behaving as a random variable x. And here also when you are observing continuous random process at any time instant t equal to t, this x also becomes random variable, and in this particular case it is discrete random variable. So this formula is basically our working formula, and this is the general formula which we can use for the mean. So whenever you have to calculate the mean of a random process, we have to calculate the mean of the random variable at each sample instant. So in this case, what we are doing, we are first fixing this t and then we are calculating the mean. So more clearly you can understand it something like this, that if x of t is continuous time random process and I am observing it at t equal to t naught. So I will get a random variable x of t naught, and this random variable can be continuous random variable or a discrete random variable. So whenever I have to calculate the mean of this particular random process, so the mean can be written as minus infinite to infinite. The PDF of this random variable will be fx of t naught x naught, and here it will be x naught dx naught, or you can write x naught I, probability of x of t naught equal to x naught I, where I is varying. This is when x of t naught is continuous random variable, and this is when x of t naught is discrete random variable. So now let us try to understand what we are actually discussing. So first of all, what I did, I wanted to calculate the mean of the continuous time random process. So I told you that this is function of time as well as random variable. I have denoted this random variable with m. So first of all, I discussed about this working formula, that whenever you will be given a random process, you will have some time and random variable. If this random variable is continuous, then you will write this function as it is, and you will write the PDF of the random variable. Otherwise, you will write this function as it is and you will write the PDF of this particular function. Now, in general, if I have to discuss, then in general you can say that whenever you have to calculate the random process's mean, then basically you are calculating the mean at each sampling instant or each time instant. So whenever at each time instant we are calculating, then at any particular t, this x of t will behave as a random variable. Then you can calculate the mean by this formula, small x into PDF of x of t, which is behaving as a random variable. Similarly, small xi into PMF of this x of t, which at any instant is behaving as a random variable. Now, to explain it more clearly, I have shown you that this x of t is continuous time random process, and at t equal to t naught, it is behaving as a random variable. So once we got the random variable, we just need its PDF or its PMF in order to calculate its mean. So let us try to understand it by some example. So this is your first example. Suppose I have a random process x of t, which is a cos omega naught t plus theta, where a and omega naught are constants, theta is random variable uniformly distributed between 0 to 2 pi. So this is your x of t, a cos omega naught t plus theta. So here you should notice that this is the time function and this is the random variable. So it is nothing but the function of time and theta. Now, what about this theta? This theta is uniformly distributed between 0 to 2 pi. So I can always obtain the PDF of theta, which is uniformly distributed between 0 to 2 pi, and it will be 1 upon 2 pi. So from here you can say that this theta is nothing but a continuous random variable. So we have to calculate the expectation of x of t, which is nothing but mu x as a function of t, or sometimes you can also write it as xt bar So this x of t is a cos omega naught t plus theta. We have just now seen how to operate this expectation operator. Since this a is constant, so it will come out of this expectation operator. So it will become cos omega naught t plus theta. Now I will observe that here the random variable is theta and it is also a continuous random variable. So you can write it as a minus infinite to infinite, this particular function cos omega naught t plus theta into, now we do not need the PDF of this complete cos omega naught t plus theta. We just need the PDF of the random nature of the random process. So I can write it like this. So basically you have to calculate expectation of x of t, which came out to be a cos omega naught t plus theta. We observed this time instant and this CRV, and we know how to open this expectation operator. So this expectation operator becomes minus infinite to infinite cos omega naught t plus theta f theta of theta d theta. Now we know that f theta exists between 0 to 2 pi, so I can write it as a by 2 pi 0 to 2 pi cos omega naught t plus theta d theta, because between 0 to 2 pi the function of this PDF contains the value of 1 upon 2 pi. So I have written something like this. Now how to solve this? If I have to solve this, so I can write it as a upon 2 pi 0 to 2 pi cos theta plus omega naught t d theta, because integration is with respect to theta, that is why I have written theta first. So if I will integrate it, I will get sine theta plus omega naught t. Here omega naught t is behaving as a constant because differentiation or integration is with respect to theta. So I will put a upon 2 pi, it will become sine 2 pi plus omega naught t minus sine omega naught t. You know that sine 2 pi plus theta will become sine theta, so it becomes a upon 2 pi sine omega naught t minus sine omega naught t, and the difference becomes 0. So this is the calculation of the mean. Now you can see that whenever I have calculated the mean of x of t or mu x of t, it is nowhere depending upon the time, which means the mean will always be 0 for all the random variables which you can obtain by observing this random process x of t. So you can say that if the mean of this x of t or the expectation of x of t is 0, so if I will observe at any time instant, this mean is going to be 0. So whenever for any random process the mean comes out to be constant or time independent, which means the mean of the random process as well as the mean of the random variables obtained at different time instance will be same. So you can say that in this case the mean of the random process, because we have calculated this expression expectation of xt, it will always be equal to the means of random variables which you can obtain by observing the random process at different time instances. So in this particular case we can say that the ensemble mean is always going to be 0, because expectation of x of t is 0. Then if I would have taken t1 instead of this t, then the result would not have changed, or t2 instead of this t, then result would not have changed, or any other value of t, then the result will always would have been 0. That is why we can say that the mean of this particular random process is independent of time. So the mean of the random process x of t is independent of time. Or the mean will be same at each time instant. The mean will be same at each time instant. Let us try to understand another example. In this example, what I'm doing, I am taking a random process x of t, a cos omega naught t plus theta, where where omega naught and theta are constants, and a is random variable which take values 1 and -1 with equal probability. So this is your x of t in this particular case, which is a cos omega naught t plus theta. So you can see that this is the random variable and this is the time behavior. Rest omega naught and theta are constant, so it is also the function of a and theta. Now you can see that a is having only two values, and also the probability of those two values are given as same. So whenever a takes value 1 or -1, the probability of these two events are same. So you can say that this x of t is nothing but the function of, this is a comma t. It is the function of a random variable and time, and this random variable is a discrete random variable, and this is your time. So this is basically representing that a is your discrete random variable. Now we are interested in the mean of xt. So the mean of xt, which you can also write it, will be expectation of a cos omega naught t plus theta. We know that expectation operator operates only on the random nature. So from here you can see that this omega naught is constant, time is always deterministic, theta is also constant. So this cos omega naught t plus theta is always going to be deterministic. This is always going to be deterministic. We know that expectation operator operates only on the random nature, and this expectation of a is a discrete random variable. So we can see that at each time instance, this cos omega naught t plus theta will be deterministic, or it will have a constant value. That is why we are saying that expectation operator will treat this deterministic signal as constant. So we can write it as cos omega naught t plus theta into expectation of a. Now you know that whenever we have to calculate the expectation of a discrete random variable, we can always write it like cos omega naught t plus theta into summation of probability a equal to some values, say ai, into a equal to ai. So from here you can say that this expectation of a cos omega naught t plus theta is written as cos omega naught t plus theta into expectation of a. So to write the expectation of a, what you can do, you can write probability of a equal to 1 into a equal to 1 plus a equal to -1 probability of a equal to -1. This is how we used to calculate the PMF. So this becomes cos omega naught t plus theta. Probability of a equal to 1 is half, and here the value of a is 1. Probability of a equal to -1 is also half, and value of a is -1. So it becomes 0. In this case also you can see that the mean of the random process is independent of time, or you can say that the mean will be constant at each time instant, or the mean of the random process will be same as the random variables obtained at different time instances. Now let me explain another example. So all these examples are important. It will create a base to understand the process of the randomness in a signal. Now let us take another example. In this case again I am taking this random process a cos omega naught t plus theta. Now where a and omega naught are constants and theta is random variable and it takes two values minus pi by 2 and pi by 2 with equal probability. So here also you have to calculate the mean. So the mean x bar t becomes expectation of xt, which is expectation of a cos omega naught t plus theta. Expectation operator operates only on the random signals or random variables. So you can very clearly see that a is constant. Here omega naught is constant. T is always deterministic. The time nature is always deterministic. But theta is your random variable. So I can take this expectation operator as constant and it will become cos omega naught t plus theta. Now you can very clearly see that theta is taking only two values, which is minus pi by 2 and pi by 2. Also the probability of theta taking minus pi by 2 is same as theta equal to pi by 2 and it comes out to be half. So the theta will behave as a discrete random variable. So we have to calculate this expectation of cos omega naught t plus theta. In this particular case, you can see that this signal which is written inside here is not deterministic because here a discrete random variable is also present. We know that whenever the function of discrete random variable is present, you can write something like this, that cos omega naught t plus pi by 2 into probability of theta equal to pi by 2 plus cos omega naught t minus pi by 2 into probability of theta equal to minus pi by 2. So you can write here that whenever we have to write the mean of a function of a discrete random variable, we write something like this, that we will put the value of theta here and its probability, and we will put the value of theta here and its probability. So you can write it like a expectation of probability of theta equal to 1 by t becomes half, cos 90 plus theta becomes minus sine omega naught t. Similarly, probability of theta equal to minus pi by 2 becomes half, and you can write it as cos 90 minus theta. We know that cos 90 minus theta is nothing but sine theta. So in this case also, this x bar t becomes 0, or you can say that it is the time independent mean. And for this step, you should recall that expectation of f of t comma m is equal to summation of t comma m probability of m equal to mi, or you can also write it like this, probability of t comma m1 into m equal to m1 plus function t comma m2 plus probability m equal to m2 and so on. So basically this formula is used when m is discrete random variable, or your random process is function of discrete random variable. So in that case, what we have to do, you have to put the value of m in the function and its probability. So the same thing we did here. We put the value of theta in the function as pi by 2 and its probability. then we put the value of theta in the function as minus pi by 2 and its probability, and so on. So whenever you have to apply this expectation operator on a function which is a function of random variable, and that random variable is discrete random variable, so what you should do, you should put these values of m in the function and the probabilities, and you should extend this particular formula. Now let us try to understand the last example. So in the last example, what I'm doing is, suppose we have a random process a cos omega naught t plus theta. Now here a is random variable which can take values one and 2 with probability 1 by 3 comma 2 by 3 respectively, and theta is also a random variable uniformly distributed between 0 to pi, and omega naught is constant. Now it is also given that a and theta are independent random variables. So this much of information is given to us. Now this x of t is given as a cos omega naught t plus theta. Here this theta is also random variable and this is also a random variable. So first of all, let us try to understand about a. Now a can take two values, and probability of taking a as 1 is 1 by 3, and probability of a taking the value 2 is 2 by 3. So very clearly a is taking only these two values, that is why you can classify a as discrete random variable. Similarly, theta is uniformly distributed between 0 to 2 pi. So this will be the PDF of the theta, or you can say that this theta will be a continuous random variable. So this theta becomes continuous random variable. So now let us try to calculate its mean. So its mean will be mu x of t or x of t bar, or expectation of a cos omega naught t plus theta. We know that expectation operator operates only on random nature, random signal, or random variable. So you can see that this a is random variable and this particular function is also function of random variable, or you can say this is a random signal. So expectation operator operates only on random variables and random signals. It does not operate on any deterministic signal. So from here you can say that this a is random variable, and here this cos omega naught t theta, this particular portion is deterministic, because at each time instant you will get a constant value or a defined value. So that is why this particular portion is deterministic, but this theta becomes random variable. That is why this overall signal becomes a random signal. Now it is given that this expectation of a cos omega naught t plus theta has a and theta as random variables which are independent. So we know that whenever a random variable a and theta are independent, then their functions will also be random variables and they will also be independent. So we can say that this a and cos theta plus omega naught t will also be independent. So whenever we know that x and y are two independent random variables, so we can write expectation of x into expectation of y. Here also, these two random variables a and cos theta plus omega naught t are independent in nature. That is why I can write it as expectation of a into expectation of cos theta plus omega naught t. So here you can say that this random variable a and the random variables obtained from this signal for each value of t will be independent. So this is your random variable and this is your random signal. So you can say that the random variable obtained at each time instant of this random signal will be independent with this random variable, because this random signal and random variables are independent with each other. Whenever a random signal is independent with a random variable, which means the random variables obtained at each sampling instant of that random signal will be independent with the given random variable. Now, this is your discrete random variable and this is your continuous random variable. So what we can write, we can extend this as a equal to 1 into probability of a equal to 1 plus a equal to 2 into probability of a equal to 2. So this is your expectation of a. What will be this? We know that since it is a function of continuous random variable, so we have to use the integration minus infinite to infinite cos theta plus omega naught t and PDF of theta here. So probability of a is 1 by 3 and probability of 2 is 2 by 3. So it becomes something like this. We know that this theta lies between 0 to 2 pi and it has value of 1 pi. So you can write it as 1 by pi 0 to pi cos theta plus omega naught t d theta. So this expectation of x of t becomes 1 into 1 by 3, 2 into 2 by 3 into 1 upon pi 0 to pi cos theta plus omega naught t d theta. So this will become 5 by 3 pi and you can write it as sine theta plus omega naught t and the limit will be from 0 to 2 pi. So it becomes 5 upon 3 pi and it becomes sine pi plus omega naught t minus sine omega naught t. We know that sine 180 plus theta will be minus sine theta. So it will become minus 10 upon 3 pi sine omega naught t. So in this case, you can see that the mean that we obtained is not constant, rather it is a function of time. Or you can say that whenever this particular random process is observed at different time instances, at each time instance the mean will be different. Or in other way, you can say that all the random variables which are being observed by this random process at different time instances will have different mean. So we cannot say that it is a constant mean random process, or we should say that it is a variable mean random process. So this ensemble mean will give different values at different time instances, which means the random variables that we will be getting at different time instances by observing this random process will have different means. So this discussion was very important.
So hopefully we have understood every concept in this class. If you have any doubt in any concept, you can let me know in the comment section. I'll try to resolve that thing. Apart from that, you can also follow me on various social media platforms. For example, you can join this Telegram group where you will be getting important notification, important updates. This is Telegram group where you can also comment, you can ask your queries, or maybe you can also suggest me for the improvement. Apart from that, this is my Unacademy profile. On this Unacademy profile, you should also follow me so that you can get the important updates of the Unacademy also, right? And this is the Notion page. You just have to type this tiny.cc/VishalGate. So you will be redirected to a page where all the special classes are arranged very systematically. तो मैंने बहुत सारे टॉपिक्स पे स्पेशल क्लास ले रखी है. फॉर एग्जाम्पल नाइक्विस्ट, फूरियर सीरीज, latches and flip flop, double integrations, okay, lot of things are there. So you will be getting all these concepts absolutely free of cost. You just have to type this in your URL, you will be redirected to that page and attend these lectures one by one. You will be getting a next level confidence in these topics, that I can guarantee you. Now this is the Notion page of your YouTube, on which you will be getting the links of the YouTube. Apart from that, you will be also getting the PDFs of that particular lecture. So this is very important for you, and just you have to type http://bit.ly/GATE live. So GATE live, you just have to type it in the capital so that you can access all the lectures link and PDF arranged systematically. So if you want to attend or you want to clear the examination with the free resource, then this is the channel for you. This is the best recorded videos which has been ever made. You just have to go to that lecture, just click the link and download the PDF and start studying systematically. So we have also done this for you, so that any student, whether he is sitting any part of this country, should not face the difficulty in cracking the examination, whether he can afford or he cannot. Now if you can afford, then the subscription prices are not something which you cannot pay. It is very nominal amount which you can pay, and you can just avoid all the distractions, all the time wastage which we will be doing in downloading those PDFs, arranging them, arranging for the test series, and a lot of other things that you have to arrange, doubt solvings you have to arrange by yourself. If you want to avoid all those distractions in a very nominal amount, so you can go for the Unacademy Plus subscription. For 12-month subscription, you have to pay only 74 rupees per day. Apart from that, for 18-month subscription, which is the best possible subscription, you have to pay 63 rupees per day. It is even lesser than the pizzas that you order on your home. So it is that much of amount that can shape your career, that can give you the best possible rank in the examinations under the guidance of the best teachers of the country, which has been right now placed on the Unacademy. Now 24-month subscription will cost you 54 rupees per day. So these subscription amounts will give you the subscription for the desired period. Apart from that, if you are using this code, you just have to remember this code, write my name, write GATE after it. You can also write ESE after it. So you have to write my name and write ESE after it. So any one of these code, once you apply, you will be immediately getting the 10% discount. You will be getting all the features of the Unacademy. You will be getting the guidance of all the teachers present on Unacademy, and everything you will be getting that is needed to crack the examination once you are using this code. So if you think we are working hard, we are giving our best content, we are giving the free content absolutely for you guys, and everything that is needed for every student to crack the examination. So never forget to use this code whenever you are taking the subscription. So this code is very important, and you have to use every time you are taking the subscription. Now those who are interested for the prices, total price amount, so let me tell you, total price is 27,225 for 12 month, 34,650 for 18, and for 24 month it is 39,600. You can also pay this by using zero cost EMI. Zero cost EMI can be paid by credit card and debit card. In debit cards, there are only Bajaj and HDFC as of now available. Okay, so the zero cost EMI means you do not have to pay anything extra. Any interest is not, you should not pay, and you have to pay this much of amount on the daily basis if you are looking for the zero cost EMI option. Apart from that, if you are coming for Iconic subscription, so Iconic mein, I have already told you that your personal coach will be the game changer. He will be he will be basically following you to give you the guidance so that you can get the success in a very short span of time. So he will be following you, he will be pushing you every time. Now once you use this coupon code, this will be costing you around 45,225, and if you are using this coupon code, write my name, GATE after it, you will be getting the 24-month subscription of Iconic in 66,600 rupees. Fine. Apart from that, every one of you should follow this GATE aspirant group, and there also some important notification always comes. Now what are the YouTube channels that you should immediately subscribe? This Kreatryx, this is the channel on which you are present. This is Unacademy GATE questions, where previous year questions has been solved by the educators. So you'll be getting all the previous year questions video solution apart from the PDF also. This is the Electrical Junction channel, where you will be getting the important concepts of ECE and electrical, and this is Engineering Pathshala, where you will be getting some practical aspect of the videos, some animated videos that will enhance your ability to think. So these are the channels which you should immediately subscribe so that you can get a better content. Fine. Now these are my some YouTube videos which I have created for you. In all of these videos will give you some motivation, guidance, content, and some strategy. So these are hand-picked videos. You can immediately follow these videos. Okay, so thank you so much. And those who are coming on this channel, immediately share all the content which is present on this channel. We are working very hard for you guys. So this is your responsibility that you should share this channel. You should subscribe this channel. Also share the link of this channel, link of the videos, link of the educator whom you follow, so that every student who is needy, they can come onto this channel and they can get the best possible rank. So all the best everyone. Let's crack it.